are showing is something you can build out of seawater.
Go put it back.
And aluminum cans that you pick out of the water, and some chamois.
Yeah, take out of the water.
Is that right?
Yeah, look.
This is an aluminum air battery, aluminum air fuel cell.
Well, how you make the two, what do you got inside there? What's in the water now?
Salt
They're
water.
going to tell you about it.
Is there seawater in there now?
Yeah,
Or
just-
some kind of water?
Well, it's not really seawater, but it could have been.
Well, what this
What's in there
Yes.
now? What's in there?
what this contains is this is a plastic cell.
Yeah.
Over here we have an air anode that allows air to permeate the water, but doesn't allow this water to come through. The water is a seawater solution, a saltwater solution right now, although as mentioned could be seawater, could be potassium or sodium hydroxide.
Drano.
Or Drano. This is an aluminum. This is an aluminum anode, and it's not pure aluminum. It's slightly alloyed to make it more efficient in the cell. I don't know what the alloys are.
It makes it more corrosive.
It makes it more corrosive, exactly. And
Sorry, Erlen.
Sorry.
Right.
Lower grade stainless.
What'd you say
Yeah,
about
you
the
want to
front?
try this with pure aluminum. Here's regular sheet stock aluminum.
Yeah, that
You
one.
can try this and see what
This
happens.
is an important experiment. That'll be cleaned up.
Go clean this up first.
Steve, what's in the front that you said there was a filter of some kind or a separator?
It's oxygen and air in.
Yeah, this is the air cathode. This is the aluminum anode.
Now, are you saying if we run this backwards and put current on it,
You'll get hydrogen off.
we would get hydrogen off?
Remember, hydrogen is more noble than aluminum in the electromotive series.
So we would get hydrogen
You
off.
would get hydrogen off. Also, this one, you'd get chlorine, which would, Steve would cry because it would make it hard on his air breather.
Yes, it would.
On your what?
On the air cathode, it would contaminate
The
it.
separator of the oxygen
Corrode it.
thing wouldn't work, am I correct?
That's true.
So what is that thing made out of? This stuff?
It works is on a two-stroke principle
Yeah, you're in the sunshine.
in which there are 4 cylinders on this end and a mirror image set of 4 cylinders on this end. And instead of using a crankshaft to articulate the motion of the pistons, it uses a cam. And on each side of the cam there are 3 lobes. The result of which is that you can reduce the frequency of the piston by 3 to the output shaft, which gives you a torque multiplier of 3 in this configuration. He's designed it so you utilize the peculiar properties of hydrogen to get a new result. He burns the world's fastest burning fuel, hydrogen, and so he can operate a cycle for the piston at a much higher rate than would be allowed for efficient use of the heat released in a crank articulated engine. But he gets the advantage, again, of multiplying the torque by 3, so he has a high torque even at low output RPM engine. He also makes use of free breathing principles. He uses more air, which gives him more insulation on the piston, the cylinder walls, and the head, so he conserves more heat for the expansion than ordinary engines. So in operation, he's injecting fuel here at the top of the cylinder, like we would here, and delivering that heat within surplus air each time the piston's up. So he gets a much more efficient use of materials. He has twice as many strokes as a 4-stroke would have had. He has a very low side thrust on his piston assembly because there's no side motion trying to push the piston from the crank. It's a
Straight linear
push, which is much more efficient.
Right.
Each power stroke of this piston is a compression stroke of this piston, and the power stroke of this one's a compression stroke of this one.
That's all in one
And there's a,
yeah.
that's right, there's a rod between.
Did they ever produce any of these? Have they got any production?
He's at the stage of finishing the design for production.
Oh.
His specialty is tooling. So he's designed it for manufacturability and for reducing the part cost and the components cost and the system cost for the same horsepower as much more complex, larger engines.
You should bring an 871 down here. The numbers are just about the same.
Y'all
That
will put
engine
one on
weighs
a race car.
6,000 pounds.
You bring
It's
it
got
over
the
here.
same horsepower, same torque about as this engine does. It weighs less than 250.
And the 671 would also waste a lot of heat that this one is conserving. In terms of where the heat goes, if you start tracking the heat release to motive power production, that's a result. So here's a Viking Larson who's challenging the world record out of a bill of materials that's only this big compared to,
871.
which is a big inventory of Earth's
When you were
resources.
fitting that blue box right,
It wouldn't do it.
So how many horsepower might this be?
300, over 300 from this full-scale mock-up.
Wow. And it was going to weigh how much?
Less than 300 pounds by far, probably less than 230 pounds.
Geez, so a pound per horsepower, less than that.
That's right. Anyway,
And how about manufacturing costs on this? It seems to me that it would be much less to manufacture something like that too.
less in virtually every quantity, even in research quantities.
He asked a couple of questions. Can we stand that up and make it run?
Absolutely. It's just as happy on.
Years ago, we went through the Chrysler engine and stood them up. We couldn't make them run because the bearings, the end thrust bearings.
Thrust bearings, they-
We gained
The best one.
14 or 16% horsepower, not having to go through a gearbox for all these irrigation. I mean, first thing off the bat, that looks like an absolute.
This one's happy vertical.
Okay, that's what I was gonna say. Plus, it looks to me like if the pistons were standing up, even the weight of the piston wouldn't be against the other side.
No, it turns out it's against an air cushion.
Right, so it looks like it'd be better standing up than just from my
You would
standpoint.
think so.
How would you lubricate that, Walter? Roger? How would you
I'm not
lubricate?
worried about the lubrication of it. I mean, that's his job. I'm not worried about how it runs. But we put on several hundred of these Chrysler vertical engines, and in theory, it was great.
We've made a barbecue also with a sodium organic so that people can be aware of where the fire is.
Take a picture of Steve taking pictures.
Yeah, that's good. That's good.
About sodium?
Well, we've made the flame more visible. If you notice, we made it more luminous. Yeah.
Roy, how did you make the hydrogen for that cylinder?
That hydrogen was actually made by an electrolysis process. That's using anybody's energy. It probably came mostly from nuclear power, maybe from 40% or 30% coal and the rest nuclear.
Okay, crank it up, Roy.
Gotta be a white sock, right? You need a white sock. Yeah. How about a handkerchief?
Dust, no black lung, and that they would